Why don't we go ahead and get started? Welcome, everybody. I'm Cliff Lynch. I'm the director of the Coalition for Networked Information, and I'll be introducing this session today. You have reached one of the project briefing sessions that's part of week 3 of the fall 2020 virtual CNI membership meeting. And just to remind you, week 3 is themed around technology standards and infrastructure. All 3 of those are quite relevant here, I think. This session is being recorded. The recording will be available subsequently. There is closed captioning available. There is chat available, and please feel free to use that throughout the session. We also have a Q&A tool. After we hear all of the presentations at this session, Diane Goldenberg-Hart from CNI will moderate a Q&A session. Please feel free to put questions in at any point during the presentation, and we'll try and address as many as possible at the end. I want to note that we have had a change in speakers here. Jessica Meyerson is not with us today, but Ewan Cochran from Yale is joining his colleagues Seth Anderson and Ethan Gates, both also from Yale. A little background on this project. This is one of these really deeply strategic projects that's trying to really build out a robust service for emulating software in obsolete environments. So it's a fundamental cornerstone of software preservation strategy. It's been going on for a while. It's received funding from Mellon and Sloan Foundations both, and it has very close connections to the wonderful work of the Software Preservation Network, although the Yale Library has been the sort of technological nexus of the work. I do want to note also, for those of you who were with us earlier this week, Natalie Myers and her colleagues at the University of Notre Dame have been doing some very interesting interlinkage, integration between the work that's being reported here and their work on PressQT. If you're interested in what you hear here, you may want to go back and look at the video of the presentation from that session. And with that, I just want to thank our speakers from Yale for coming to update us on this really important project. And I'll turn it over to Seth to start the presentations.
All right, thank you, Cliff. Good afternoon and greetings from New Haven, Connecticut, my home office here. It's a shame we can't meet in person. I always enjoy the opportunity to see folks face to face and talk about our project, but we are thrilled to be here virtually to provide an update on the EaaSI program of work. So as Cliff mentioned, I am Seth Anderson, the Software Preservation Program Manager at Yale University Library and the co-PI on the EaaSI program. And I'm joined today by Ewan Cochran, who is the Digital Preservation Manager at Yale and my co-PI, who's joining us from New Zealand. And I'm also joined by Ethan Gates, our Software Preservation Analyst and User Support Lead for EaaSI. So in July of this year, EaaSI entered its second phase of the program, thanks to the continued funding from the Sloan and Mellon Foundations. And we are excited to share an update on where we've come since our last presentation on EaaSI at CNI, which was in the spring of 2019. And then we're going to look ahead at our plans for this next 2-year round of funding, and then demonstrate some of the work that we have completed over the last couple of years, and some new functionality that we're hoping to incorporate into the system in the coming year and a half. So let me just, okay, there we go. So Cliff gave a pretty good summary of what EaaSI is, but I will just venture to give a little more detail before diving into our project timeline. So we like to think of EaaSI as the combination of the emulation as a service technology and additional sort of user-oriented functionality that we've been developing. A combination of that technology, the services that we provide to our users to support their use of the system, and then also that community of users that are aiding us in determining a roadmap for EaaSI, helping us figure out what new features we need to prioritize, but also just generally helping us chart a path through what is the still developing and maturing practice of software preservation and access through emulation. So for those of you who aren't aware, EaaSI is built on the emulation as a service framework, which was originally developed at the University of Freiburg and continues to be developed by OpenSLX, which is a company of developers from that original team at Freiburg. And the service allows users to create, manage, and access emulation environments through a web-based interface so that they can then load their own digital collections materials into emulated computer systems that contain sort of underlying software required to render and manipulate those digital materials. So if, for instance, you have old word processing documents in a collection, you can then load those into a computer environment that contains the compatible software and provide sort of authentic or as close to authentic access to those materials as is possible using the emulation service. Our team is made up of 3 of us from Yale, plus the developers from OpenSLX, and we also receive support from Jessica Meyerson at Educopia, and Kat Thornton, who is the leader of the Wikidata for Digital Preservation program and serves as our semantic architect in helping us utilize and distribute the metadata that we have been creating as part of our ongoing work on EaaSI. So just give a quick update from where we've come since spring of 2019. I believe at that time we were still in the early days of having just put out our first beta release of the EaaSI software, and that included the EaaSI network software, which I forgot to mention, which allows the users of EaaSI to exchange and reuse software installation materials and pre-configured emulation environments from other organizations to provide access to their materials. So if you have need of a software title that you don't have locally, either at your institution or even within your own EaaSI system, you can copy that to your infrastructure and run it and reuse it as however you need. So in 2019, we worked on the beta release of EaaSI with the network, and we provided that to our initial set of network institutions or nodes, which included Notre Dame, who are here today, Stanford, UC San Diego. Let me see if I can get them all. Carnegie Mellon and University of Virginia, plus Yale acting as its own node. I don't think I left anyone out of that first group. Over the summer, shortly after the meeting in spring of 2019, we released a public version of the EaaSI system, which contains sort of just example versions of open source operating systems and software that anyone on the web can access and poke around in, just to give an idea of the kinds of legacy software you can interact with and through emulation. And that'll come up in a moment when looking forward in the next 1.5 years. And then throughout 2019, we continued to work on an updated interface for EaaSI. And so that was released in early 2020, around March or April. And this was a huge undertaking that we were able to complete with the aid of the software development company Portal Media out of Wisconsin. And it provides a more intuitive and user-friendly interface to search and discover the environments and software that would be available in an EaaSI system. It will have additional features for documentation that we hope to implement sometime soon. And then also just has additional administrative features. So for instance, you can create user accounts now. We have role specifications that control the actions that certain user types are permitted to perform. And it just generally looks and feels a little bit better than previous versions of the system. So that has been in the hands of our users since April, and we continue to tinker with it. And it is, part of the focus of this next 2 years, which started in July, is to see what happens when users have access to this version of the system, and to learn from that and continue to improve the system. So we have a number of targets that we've set for ourselves during this next 2 years. There are some more R&D focused development features that we'll be working on, including incorporation of emulation of mobile systems, in particular the Android operating system that is open source and Google developed. We'll be incorporating support for emulating computer networks. And we're going to continue to improve on a number of automation features that we've started prototyping, and we'll incorporate into the interface to further simplify the process of creating and manipulating or customizing your emulation environments. But I would say our real focus over this next 2 years is establishing EaaSI as a service, even though it's there in the title. One of the things that we've learned over the first 2.5 years of the project is just how difficult it is to support a growing number of users. And as we continue to scale up the system, we want to make sure that we have a mature and well thought out and that we have the capacity to support a growing number of institutions that will hopefully be using EaaSI. So with that in mind, we're putting a lot of emphasis on ensuring the stability of the software and the code that underlies the EaaSI interface and the back end. And we're taking a real look at the support services we provide. So making sure that we have the mechanisms to allow users to report bugs or ask questions or seek advice on the use of the system, and then use the expertise that we as a team have developed over a number of years to enable and empower the users of the system to implement it effectively. And then finally, we are really emphasizing sustainability, both from an organizational standpoint and from a technological standpoint. So like I said, we're looking at making sure we have a stable system, but also we want, by the end of this funding period, to, in some way, and we don't exactly know the scope of this yet, but start providing an EaaSI service, with a service model and sort of payment mechanisms, so that we can continue to sustain the work that goes into EaaSI, and continue to expand its functionality and expand the community of users that are participating in using the system. So just a few other highlights from our timeline, just to give you a sense of where we are headed. So for the past 6 months, we've been working on a new edition of the system, which will be the hosted edition. So currently all the users have it installed on their local infrastructure, but we've seen a need, certainly over the last year, for a version of this that is supported and has infrastructure provided by the EaaSI program, so that institutions that maybe don't have the funds or sufficient IT support can still use EaaSI, and they will then just use the hosted edition of that. And to test that out, we have arranged with the Software Preservation Network to do a pilot program through most of 2021, wherein the current membership of SPIN will have the option to elect to use this hosted edition, and we'll be monitoring and guiding activities with them to again, learn what it looks like when we add more users into the system, and what it looks like to the team and our capacity to manage a larger scale of a larger user base. So then towards the end of, sorry, I can't, my screen's a little too crowded. Towards the end of this funding period, we also hope to turn that public sandbox version of EaaSI into a functional node, so that individuals who maybe are unable to use EaaSI through an institutional, through their institution, or just members of communities outside of sort of institutional frameworks who want to use emulation, will have an opportunity to do so through the public node. And that will, again, only include open source software, but we anticipate, given the breadth of software available from the open source community, that will be a valuable platform for both exploring the history of open source software, but also using it as a tool to access order collections. So those are our plans. And as I mentioned, we wanted to spend most of our time today demonstrating some of the work we're doing. So I will first be giving a demo of an upcoming service that we're going to be releasing at the library, the Yale University Library Emulation Viewer. Then Ethan's going to give a demo of the Universal Virtual Interactor, which is the sort of engine of our automation functionality. And then Ewan is going to show off our ability to emulate computer networks and talk about how that will be a sort of powerful feature in the system coming up in the next couple of years. So let me just take a breath before I dive into demo mode. And of course, certainly, please feel free to post any questions that you have in the Q&A, and we'll get to them in a second. All right, so that is, okay. The Emulation Viewer is a service that will be released to the Yale community starting next year. And it is based on some work. I'm going to pause that before it gets ahead of me. That was started by Ewan when he started at Yale to create digital copies of the CD-ROMs in the library circulating collection with an eye towards using emulation to provide access in the future. When I started in 2017, we were taking our first steps towards configuring emulation environments featuring the CD-ROM titles from the library. And what I'm trying to demonstrate here is just how many we have. There are thousands of disks that are in the circulating collection, which are rarely accessed because of the obsolescence, general obsolescence of the CD-ROM format. And a lot of these are very interesting, and we hope that they will be helpful to researchers. And so the idea, I'm going to walk you through the workflow that we foresee, even though it's still in the works in some cases. But the idea is that the emulation environment and the viewer that users will access exists in the same way as you would say like an ebook reader in the library's infrastructure. Users will, search through Yale's various catalog formats, and there will be a link as I'm circling here, where now you have this option to request the physical copy, but instead you would have a link that says view the emulation, or I don't recall exactly what the text would be. And then when you click through that link, you'll be taken to this viewer that's displaying right now. And users have, a limited set of functionality. We're not offering them the ability to like save changes or print or do any sort of robust manipulation of the contents of these disks. But these environments, which have been set up by student workers, and we thank them for their service, have been set up to quickly get the user to the contents of the disk. So as you saw there, the environment brought up this viewer, which then goes to an HTML page. And from there, you can click through the materials in this title on neurochemistry. We also are setting certain restrictions on the service. So you do have to sign in through Yale's authentication service. So if you don't have a Yale account, you will not have access to these materials. And then we've also limited access to one environment at a time. So if a user tries to log in while someone else is accessing it, they will not be able to, and will have to return later when the person is no longer taking their seat. So like I said, that'll be made available in January, and we're very excited to see what the response looks like. But I will now just quickly, change slides because I'm already over time. One other thing I just want to point out is that we're using this work as well to serve as the basis of a separate service that we're going to make available to other institutions, wherein all of these CD-ROM environments that we've configured will be available for institutions to, say, match up with their own collections. And then they'll be provided a link to a separate type of access page. It's not exactly the same as the one that Yale is using now, but they'll be able to skin it and align the sort of header and information to their look and feel for their institution. I'm glossing over this, so please feel free to ask questions about that when we enter into the Q&A. So this is what the access page would eventually look like. So that was very quick, I realize. So as I said, please, if you have questions, we'll discuss a little later, but I'll now turn it over to Ethan to talk about the UVI.
Thank you. And can you hold off on a second before you start playing that video? I'll give you a heads up, Seth. But yeah, I'm really excited to share with you all our advances in over the past year or so in what we call our EaaSI API, the Universal Virtual Interactor, or the UVI. And what the UVI does is it basically allows users to query the emulated environments that are available in the EaaSI network based on an input file or set of files. And once those files are uploaded or provided to the UVI, the UVI's automatic file characterization matches those input files with software that can render that file. The API can either return that metadata, so just providing the user with some useful information about what computing systems or applications could open and interact with that file. And it can even return the emulated environment itself with the file mounted in it for interaction via emulation via the browser. So if we could start up our demo video here, Seth, I'm going to show exactly what that means if I upload into our demonstration UVI interface an older spreadsheet file. We can see that the UVI will return 2 results based on that automatic characterization that concludes this is in fact an Excel version 3.0 file format file. One environment runs Windows 95 and Corel WordPerfect suite, which is what we're loading up first. And the other result returned Windows 98 plus Microsoft Office 97, both of them capable of opening this file in theory. So if I click render, as I just did in the demo video here, on the first suggestion, we receive a running Windows 95 emulation and even automatically mount and open the provided spreadsheet in the specified application, WordPerfect Quattro. And at that point, you're free to interact and view your given file, but you also have the option to compare with the UVI's other suggested results. So again, in the video I just showed, I clicked on alternative results, click on alternative environment, and switch over to the Windows 98 plus Office 97 environment. And after a minute, we'll get the exact same file, this time just running in a different application. So you can see in this case also that there is some content in the spreadsheet that was not properly rendered in the WordPerfect application a minute ago. So this ability to compare different emulations, different applications, different renderings, even if there are multiple environments, multiple applications technically capable of reading the same file format, is really critical for assessment, evaluation, and proper access of legacy digital content moving in the future. And finally, at the tail end of the video there, you're see that because we allowed data export at the beginning of this process, we can even use Office 97 as a conversion or a migration tool, saving out the Excel 3.0 file to a newer format, something that would be legible perhaps in Office 365, and receive that converted file as output. So again, we can use it both as an assessment, as an access, and a migration tool. Next slide, please. The UVI is also capable of working with more complex multi-file sets, as we are demonstrating here by this data set from the Yale Institute for Social and Policy Studies' data archive. Here we've selected a legacy Stata script from the archive along with a number of additional data files that the script is intended to be run against. The automatic file characterization again identifies an appropriate rendering application environment, in this case Windows XP with Stata 10. And renders that input. I'll admit that these videos are slightly sped up just for the sake of presentation, but at the tail end of this video, you should glimpse the Stata script, again, just automatically starting to run mounted in the Windows XP environment and automatically run by Stata 10. The Stata script just takes a little while to actually crunch the data and actually produce any output. But by doing so, that's just not why we're showing it right here to you today, but by doing so, you can verifiably go back and verify the results of the associated study that this data set was a part of that was originally published in, I believe, about 2006. So really important for data reproducibility moving into the future. And next slide, please. These videos have shown off what you've been seeing is our demo interface for testing and demonstrating UVI functionality, but it is also important to emphasize that the UVI is an API. It is ultimately meant to be used with and integrated into broader preservation and data curation tools, workflows. To that end, we have been working with the University of Notre Dame on their Analyst-funded PresQT file transfer web application, as Seth mentioned earlier, and Natalie is, I believe, actually here in the call, and the Notre Dame team spoke more about the PresQT project earlier at CNI earlier this week, so do go check that out. And Natalie, do call me out in the chat if I mischaracterize anything here. But the PresQT platform is intended to enhance reproducibility and open sharing of resource data. And their initial work does involve an easy service integration via the UVI API. So let's say you have a set of files stored in OSF, like perhaps a set of research about what it would take to build a universal virtual interactor. And once you've transferred those files into PresQT, you'll have the option of selecting the easy service, as this button shows. And next slide, please. If you click on that button, it submits the contents of that OSF project or GitHub, whatever the source project is, submits that data to the UVI for the exact same process of characterization that we just demonstrated, and returning information about what software and environments could render those files and get them all packaged up and deposited, that metadata packaged up and deposited along with the files for the long-term stability and characterization of that data. Yep, nope, perfect. Last slide, please. And since so much of the UVI work is dependent on that whole process of automatic file characterization and matching of file formats with the software that created it or that can open them, I'll also note that Yale has been working with independent developer Ross Spencer to create a version of the file characterization tool Siegfried that integrates Wikidata identifiers. And Wikidata is really important because Wikidata already associates hundreds, I mean, thousands of file formats with compatible software applications. And there are, more such associations by the day, thanks to our colleague Kat Thornton in the WikiDP project. So by piggybacking on that Wikidata work via the Siegfried development, even more of the process that I've been describing with the UVI can be automated, cutting down on the amount of redundant documentation of reassociating file formats with software applications. And between that and just the growing number of environments and legacy software applications that we have in the EaaSI network, the UVI's recommendations and functionality are just going to get better and better and better over time as more people join and upload to the network. And that's all from me. So I'll hand it off to you and to talk about networks.
Okay. Good afternoon, all. I just want to say, in relation to what Ethan was just talking about, Ross has donated his time to do that work, integrating Wikidata with Siegfried, and I want to thank him very much for that. It's been a lot of hours from him, and he's going to release a report at some point, I think, which I'll share, and it has a lot of information in there about how much time he spent and just the amount of work that's gone into this, but I'm really excited about what he's been able to do. So I just wanted to briefly talk about what we've got coming up around adding the ability to emulate entire networks in EaaSI. This has come from some work that OpenSLX have done and some other work I've been doing with the developers there on a kind of commercial offshoot. So what you're seeing here is a screenshot from some of that work where at the bottom, you probably can't make it out very easily, but you can see there are two environments. This is a configuration page for what we're calling an emulated network. And you can see there, you can actually add as many environments as you want. And then if you click on edit on one of those, this pop-up appears and you can change the settings for those environments and set things up like if you want to map a port and access the environment from your local machine using a secure proxy, we can enable that. And you can also set the network name or the URL for the machine within that network. So then if you say browse to that in a browser and it's running a web server, it'll map to that exact address. So the basic idea is you combine some machines together, you maybe even add some network services like a DHCP server or a file sharing server or an Active Directory server. And then you save that as a configured thing. It's a new type of preservable thing, so in a network of environments. And that network can then be started at any point in time, or it can be run permanently and accessed on demand. So if you go to the next slide, please. Here's an example. What you'll see is Windows Server 2003 opening up. So this is the start of a network. We're logging in there. And this particular machine is running SharePoint, I think 2007, with SQL Server. It's all embedded in one machine. Yeah, SQL Server 2005 with SharePoint 2007, I think, or maybe it's 2003. And in a minute, you'll see it'll move up to the top right there where you'll be able to, you can switch between the two machines that are in this network. So there's an XP machine running Internet Explorer 6, which is the one that was compatible with this version of SharePoint at the time. And it is networked just to that other machine. So it's isolated from the internet, making it much more secure. And only those two machines can now communicate with each other. But as you can see, it's able to access the server and you're able to interact with everything as you would have normally. And this opens up a whole world of new options for preserving the content that we all have to deal with. I think one of the most exciting ones is simply being able to preserve these large-scale databases and have meaningful ways to access them. So I mentioned briefly that you're able to access these remotely if you want to through a secure proxy service. So it's possible to say run SQL Server or any other large-scale database and access it remotely on your local machine from the emulated version. And then if you have custom clients, you can add the client into the network as well so that the users can just use that client, maybe running on a desktop machine, as we're seeing here with Internet Explorer 6 to access whatever it is you've got in the certain machine in your network. There's also all sorts of opportunities here for any sort of web-based content and complex websites where if you're able to capture the servers, you'll be able to keep them available in a very similar way to how they were available originally. So that's just kind of a teaser for what we'll be working on with networks over the next phase of the grants.
All right. Okay. So I hope that kind of got you all excited for the future of EaaSI. We have a lot more planned, obviously, and we hope to continue to expand and improve the functionality. But I would be remiss if I didn't point out, of course, that none of this would be possible without the support of our funders. I also want to make sure to thank Yale University Library for continuing to serve as the host and sort of main, the host of EaaSI as a program. And with that, we'll say thanks and open it up for Q&A.
Excellent. Thank you. Yeah, that was very exciting. Just tremendous examples of what this really powerful emulator can do. Thank you. Thanks so much for that presentation to all of you. And thank you to our attendees for joining us here today. And as Seth said, we have reserved some time here for questions. So I hope folks will jump in and share some questions with us now. Let us know what you're thinking. If you have comments as well, pop them right there into the Q&A box, and we'll be happy to address those. A quick, probably very minor question that I have. I was just wondering, you said that you're restricting access to one user at a time. Is that right? Is that what I heard?
So in the Yale emulation viewer, so that is its own separate service from, it's powered by EaaSI, but it's not the EaaSI service. So the EaaSI service, so the interface and the backend functionality of that serves as, essentially like a management system for your emulation environments that you create and provide access to. So for instance, our students go use EaaSI to find compatible environments for the CD-ROMs that they're configuring. They load the CDs into the emulator, and then they save that as an access environment.
I see.
With that access environment, we then put the link, through the magic of the web, the web page viewer. When the researcher clicks through the catalog, it's calling the EaaSI service and saying, I need to access this single environment, and that's what renders in the viewer page. And since it's a little, we have the controls. It's like, let's say if Yale had 2 copies of a CD, we could set it up to allow 2 users to access it simultaneously. We wanted to make sure we had some constraint on this, from a, well, in speaking to lawyers and also in considering the fair use arguments for this, because these were purchased items at some point in the library's past, we kind of adopted the one copy, one sort of generation policy. So while we have the option to just, the technology would allow us to open it up to as many people at once as we wanted. Put some constraints around it. It's 1 seat for 1 license, essentially.
Got it. Okay. Thank you. I appreciate that. Very good.
And if I could clarify, the EaaSI platform provides the scaffolding for whoever is implementing the service at their institution to make those decisions and constrain in any number of ways. So it could be a simultaneous sessions, it could be IP restriction. Right, again, EaaSI, the platform sort of provides the administrative interface by which any individual institution can come to their own conclusion based on their analysis with their materials of what they want to do with those.
And I should say as well, we are planning to provide more granular permissions within EaaSI for end user access. So instead of having a service outside of EaaSI that calls to the back end, to the API, the Emulation as a Service API, we are looking to have settings within the EaaSI interface. So within that system, you can see how it gets confusing, all the different versions and components of the system. But within the EaaSI system, you would hopefully have the capability, as you would with most access-oriented systems, like whatever your video streaming. So if you use Aviary, it's something similar, where you can say, only a specific user has access. So for special collections and reading room purposes, you could say this user account can access this specific environment for a week. There we're looking into potentially also restricting it to specific IP addresses. So if you needed to have it only available at a single terminal in your reading room, or if you needed to restrict it to a range of IP addresses, within, say, your university network, you could do that as well. But we're, since everybody went remote, we had hoped to get a little further along than we are now, but we obviously foresee a future where it will be highly beneficial to researchers to be able to access digital collections without having to travel to the university. And so we are excited, and I want us to be able to get there sooner, but I can't kill our developers. So
yeah,
that's what Ewan tells me.
Very good. Well, I don't see any questions in the chat right now, so I'm just going to take one last opportunity to thank our presenters for bringing this to CNI and sharing it with our community. It's really a fascinating project, and we look forward to continuing to watch its development. So thank you again for being here, and thank you to our attendees for joining us today. I'm going to go ahead and turn off the recording portion of the presentation, but any attendees who are still with us, I think our presenters will hang out with us a little bit longer for a chat. So if you want to join us, just raise your hand. I'll be happy to turn on your microphone and you can join the conversation. So thanks everybody and take care. Bye-bye.